Welcome back to Data Explained channel, where we make complex topics easy to understand. Today we talk about encoding ambiguity in data representation. Data is only useful when its meaning is clear. Encoding ambiguity arises when a data representation can be interpreted in more than one valid way. Unlike precision or range limits, which restrict what can be represented, encoding ambiguity obscures what is being represented. At its core, encoding ambiguity occurs when symbols, values, or structures lack a single, unambiguous interpretation. The data itself exists, but its meaning depends on assumptions that may not be shared. A simple example is a date written as March 4th, 2005. Without context, this representation is ambiguous. It could refer to different dates, depending on regional conventions or encoding rules. The data is syntactically valid, but semantically unclear. Encoding ambiguity appears whenever representation rules are implicit rather than explicit. Text encoding provides a common illustration. A sequence of bytes may represent readable text under one character encoding and meaningless symbols under another. The bytes have not changed, only the interpretation has. This type of ambiguity is especially dangerous because it often goes unnoticed. Systems may process ambiguous data without error, producing results that appear correct but are fundamentally wrong. Numeric encoding can also introduce ambiguity. A value of 1 might represent a count, a Boolean state, a category, or a ranking. Without a defined schema or context, the number alone is insufficient to convey meaning. Even units can be ambiguous. A value of 100 could represent meters, centimeters, dollars, or milliseconds. If units are not encoded explicitly, interpretation becomes guesswork. Encoding ambiguity is not limited to individual values. It can affect structure as well. In loosely structured data formats, such as free-form text or semi-structured records, field meaning may depend on position, naming conventions, or undocumented assumptions. Over time, as systems evolve, these assumptions drift, increasing ambiguity. Encoding ambiguity becomes particularly severe at system boundaries. When data moves between teams, services, organizations, or time periods, shared understanding cannot be assumed. What was once obvious to the original designer may be completely unclear to future users. This is why ambiguity is a leading cause of data integration failures. Two systems may use the same symbols, but assign different meanings. Or they may use different symbols to represent the same concept. Without explicit alignment, data exchange becomes unreliable. Professional data systems actively work to eliminate encoding ambiguity. They use schemas, data types, explicit units, standardized formats, and well-documented conventions. They make assumptions visible rather than implicit. Encoding ambiguity can never be fully eliminated, but it can be managed. The goal is not to make data self-explanatory, but to make its interpretation explicit, consistent, and verifiable. Understanding encoding ambiguity is essential to understanding why data fails. Most data errors are not caused by missing values or corrupted files. They are caused by mismatched interpretations. And when interpretation fails, correctness fails silently. Recognizing and addressing encoding ambiguity is therefore not just a technical concern. It is a foundational requirement for reliable data systems.